Okay, in this video tutorial I'm going to run through the properties of ionic compounds. So this is quite theoretical, a few details you need to know here, but I'm going to try and go into explaining why. Now in terms of that explaining why, you don't actually need to know too much about that, but I think it is valuable to actually understand why these things are the way they are, rather than just learning the facts. Okay, so ionic compounds often form crystals. So things around us like salt are ionic compounds, sodium chloride, and they form like salt crystals. Ionic compounds have high melting and boiling points, so you need extremely high temperatures to melt salt, let alone get it to boil. They're good insulators, so they essentially most of them are solids, and they don't conduct heat very well, or they don't tend to conduct electricity very well either. They're hard and they're brittle. So think about salt. Salt is hard, but it's brittle. It cracks, it crumbles. And lastly, they will conduct electricity, however, when they're dissolved in water. So let's have a look at why it does those things. So to better understand that, we have to look at what is ionic compounds, what makes them up, or how they're held together. So, ionic substances form giant lattices. Now, lattice just means a regular pattern or arrangement. So you can see here, this might be my sodium chloride. So the sodium would be the plus ones, the metal, and the non-metal has become negative, the chlorine. And what happens is they line up because opposites attract. If they line up, it means that the sodium can be completely, or look at this one, maybe can be completely surrounded by the negative chlorines. And the chlorines, if we look at those, the green ones, can be completely surrounded by the sodiums. So that's kind of the most stable arrangement. Everyone's kind of happy, everyone's surrounded by members of the other charge, the opposite charge. And that means there's a very strong attractive force holding them together. But because they essentially line up in such a regular arrangement, that's what causes them to form crystals. So a crystal has kind of a regular structure to it. It's got straight edges. Often they're cuboidal, like cubes, or they form other shapes like a rhombus or whatever you call them. So you get those typical crystalline shapes that have a very regular kind of shape to them. And that regular shape is just the effects of those atoms lining up in a regular kind of pattern or arrangement. The strong attractive force between them, the fact that the positives and negatives are strongly attracted to each other, means that they're held together quite tightly. So when we melt something, we have to provide enough energy to get those things moving around, sliding past each other. So that's in a liquid, the particles are all sliding past each other. In this case, to try and get the atoms, or the ions, in this case, to slide past each other and move around, is very difficult because they're locked in that pattern. They're very happy being surrounded by members of the opposite charge. If they were to start sliding past each other, it means that sometimes the positives would come closer together, and sometimes two negative ions would come closer together, and obviously there's a force kind of repelling them, and they're very much attracted to the other one. So those strong forces between the ions means that they have a high melting or boiling point. The reason they're so brittle is this. If we shift the lattice, so if we push the top half in this case to the left and the bottom half to the right, what happens is that suddenly like charges, the charges that are the same, line up next to each other. So these negatives are now going to repel rather than attract each other, and that's what causes the crack to kind of proliferate, or what actually, the moment we start to, as soon as we apply too great a force, the two sides repel each other, and you get that crack, you get a divide forming in between them. So that's actually due to the fact that when we shift it, the like charges get too close to each other, they repel, and so we get that divide. In water, what happens is the charges all separate, so they all start to float around on their own, and that means that they can actually help water to conduct electricity. Now the reason for that is that electricity is simply the flow of charge, and electrical current is the flow of charge. Now normally you've probably learnt about that being the flow of electrons through wires, but in this case, the negative or the positive particles in the liquid can actually flow through the liquid and essentially help to carry that energy, so they help to establish a flow of charge. If there are no charged particles in the water, it's very difficult to get a flow of charge. So the more charged particles in the water, the greater its capacity to establish a flow of charge, electricity. So in this case, when they're dissolved in water, they help to let electricity flow. However, as solids, they all now have a full outer shell, so none of those atoms are going to be willing to let go of their electrons, which basically means that they don't conduct, they don't let electrons flow through them. None of those, now that they've formed ions, they're happy, they've now got full outer shells, none of them are going to want to take on any extra electrons or let go of any, so electrons don't flow through them very well. Alright, so guys, those are the key properties. So if I go back to the start, they form crystals, they have high melting boiling points. That's got to do with the regular arrangement, the lattices they form, and the strong attractive force between them. They're good insulators, so in terms of an electrical sense, it's because they all have full outer shells. They're not going to let go of any of the electrons or take on any electrons, so electrons don't flow through them very well. They're hard and they're brittle. That's because the hard is that strong attractive force again, and the brittle is if we shift that lattice, we get like charges getting too close together, so they repel. And lastly, that conductivity in water is just because they dissociate, they dissolve, and so they're all floating around on their own. And having some charged particles in the water helps makes it possible to establish a flow of charge through the water. And that's exactly what electricity or current is. It's the flow of charge. So, guys, I hope that helped. A nice little quick one. But those are essentially the properties of ionic compounds you need to be aware of.